In this lesson, we will be adding and subtracting like terms. If you notice here, we have a little table here that says monomials, terms, and explanation. The 3x and the 14x are considered to be like terms because they have the same variables with the same exponents. In the same way, the 16x, y, and z squared and the negative 5x, y, z squared are like terms. Why? Because they have the same variables, and in this case z has the same exponent as well. Now 3x plus 5x are unlike terms because they have different variables even though they have the same exponent, which is the power 1, but the variables are unlike. Then lastly, the negative 3z and the negative 3z squared are also unlike terms because they have the same variable but different exponents, therefore they are unlike terms. In this other picture, we can see an example of subtracting like terms. Remember, we say we can only add and subtract like terms. We have 5 apples plus 6 bananas minus 2 bananas. Combining like terms, we know that 6 banana minus 2 banana gives us 4 bananas, which we will read as 5a plus 4b. 5a plus 4b cannot be simplified anymore, so it remains as that. That's the final answer. Alright, now we will be solving some examples for you. In this case, we have 5a plus 3b minus 2a plus b. The first thing we need to do is look at like terms. In this case, we have a 5a and we have a 2a, negative 2a. They are like terms because they have the same variable. So what we can do, we can place a rectangle here around the 5a, a rectangle around the negative 2a, just to make sure that we can clearly see the like terms. We have a 3b and a b, like terms because they have the same variable. We can place a circle around these so that we don't get mistaken. Alright, now let's rewrite it and put like terms together. 5a minus 2a, let's look at the circles, plus 3b plus b. Right, now we can add or subtract the like terms. 5a minus 2a gives us 3a. Then 3b plus b gives us 4b. And that's our answer. Secondly, 6a squared minus 3a minus 2a squared. Again, we need to look at the like terms. If you notice, we have a squared and we have an a squared. They are like terms because they have the same variable and the same power. So we can, if we want, we can place a circle around these so that we can recall these two are the same. And let's combine like terms. There is no other term listed as a, therefore we can just leave a by itself, and we will say 6a squared minus 2a squared minus 3a. 6a squared minus 2a squared can be subtracted, therefore we get 4a squared, and the 3a remains the same, and this is our answer. Thirdly, first thing we need to do, look at the like terms. We have a PQ and we have a PQ. Therefore, we will say, let's place a circle so that we don't forget these. I mean a rectangle around these. Then we have PS and we have PS. Then we can place a circle around these two so that we know they are like terms. Alright, combining rectangles to rectangles and circles to circles, we'll say 5PQ minus 3PQ plus 4PS plus 2PS. 5PQ minus 3PQ gives us 2PQ. 4PS plus 2PS gives us 6PS, and that's our answer. Last one. We have a larger equation here, expression. Let's see if we can combine like terms. We have an A, same variable. Therefore, we know these two will be combined. We have an x and we also have an x here, so let's please circle around these. We know they will be combined as well. And we are left with these, which are just numbers, whole numbers. So we can see, let's arrange it now. 10a minus 4a minus 3x plus x plus 5 plus 7, sorry, plus 5. So all terms have been used. Combine like terms now, add and subtract. 10a minus 4a gives us 6a. Negative 3x plus x gives us negative 2x. Positive 7 plus 5 gives us positive 12. And that's our answer.